Hello, good evening, ladies and gentlemen. I want to extend a warm welcome to all of you who have joined us today for this exciting webinar on the introduction to artificial intelligence and its profound potential applications in the field of medical research. As we gather here in this virtual space, we embark on a journey that explores the intersection of cutting edge technology of the future of healthcare. AI is no longer a futuristic concept. It has become an integral part of our lives, revolutionizing industries and pushing the boundaries of what is possible. In the context of medicine and research, AI is a game changer. It has the power to enhance diagnostic accuracy, accelerate drug discovery, improve patient care, and ultimately save lives. Today, we will delve into the fascinating world of AI in medicine, discussing the basics of AI, its role in healthcare, and groundbreaking applications that are transforming the landscape of medical research. So, without further ado, let's embark on this enlightening exploration of AI in medical research. I encourage you to engage, ask questions, participate actively, for together we can unlock the immense potential that AI holds in shaping the future of healthcare. Thank you for being here. And today we are joined by our speaker, Dr. Ali Bukar Maina. Dr. Ali is an AI expert with a strong educational foundation, holding a PhD in machine learning and computer vision. With over a decade of experience in diverse settings, Dr. Ali excels in AI application, particularly in medicine. His primary focus of work is on building and managing teams that take ownership of computer vision and machine learning solutions, demonstrating a strong track record in implementing a variety of machine learning image recognition models, computer vision object recognition algorithms, and cancer detection models, among others. They have also been involved in developing banknote validation algorithms predicting cancer relapse and pioneering facial image synthesis algorithms as early as 2015, where it had so much media coverage, including premium news stations such as the CNN and BBC. Without singing the trumpet too much, I would like to leave the floor to our speaker today, and let's join together and learn more from his immense experience. Dr. Ali, welcome to the studio.
Thank you, Zaid, for the kind introduction, and thank you everyone for joining. Today, I would like to talk to us about what Zaid has mentioned, the introduction to AI, and I'm going to just jump straight into the presentation without further ado. So, to start with, first question we might be asking ourselves is, what is AI, which is the short form of artificial intelligence? And in a nutshell, we can define artificial intelligence as a computer system that tries to mimic the human being. So, for instance, we are talking about mimicking human beings' cognition. That's the way we think, the way we act, the way we see, the way we hear. And this is, in a nutshell, a broad definition of artificial intelligence. And I'm sure all of you will be thinking that this is something that is very, very hard to achieve. How can a human create a computer system that imitates humans? A little bit of history will explain to us where AI has been and how far the journey has been. AI is not a new term in particular because it started long, long before now. I would say that AI started over 5 decades back, as early as the 1936, that's 1930s. I will just talk about a few milestones about on the history of AI. The first milestone I want to talk about is in the 1936. This man we're seeing is called Alan Turing. I'm sure for those that are computer science enthusiasts, the name Alan Turing is not a new name because it's a household name. So in 1936, Alan Turing introduced the Turing machine, a mathematical model of computation that describes an abstract machine. And Turing went on to prove that Turing machine can be programmed to simulate behavior of any digital computer. The Turing machine is considered to be one of the most important foundational concepts in artificial intelligence. And that was 1936, as I said. Fast forward to 20 years later, That was in 1956 then. The Dartmouth Summer Research Project was the beginning, was the invention of the name artificial intelligence. The conference is credited with popularizing the term artificial intelligence and with laying the foundation of the field of AI. 4 years later, or I would say just in the 60s, two main governments, that's the United Kingdom and United States, the Department for Defense Advanced Research Projects, that's DARPA, and the United Kingdom's government invested heavily in AI. And as a result of that, the United Kingdom even established many universities around the country, and they invested a lot in AI. And this led to researchers getting some fund and building some things at that moment that looked really, really like real groundbreaking research. For instance, there was a chatbot called Eliza, and there was a chemistry model which they used to call I can't recall the name, but yes, Eliza is one of the, yeah, Dendral. There was a model that used to look at chemicals that was called Dendral, and that was in the 60s. However, I would say that during this period, AI had overpromised, and most of what AI, the artificial intelligence researchers were saying they could achieve, was not achievable at that point in time. And this is so around the end of 60s to 70s, this government stopped funding AI research, and I think that marked the beginning of the first AI winter. So when we say AI winter, that was a period where AI just went down and there was no funding and many things happened. So research just died down at that point in time. The next milestone that I would like to talk about, which is the fourth milestone, is the 1980s. In the 1980s, there was a shift from rule-based AI to what we now is called machine learning. So when I call rule-based AI, what I mean is all the programs and anything that was called artificial intelligence that was invented before the 80s or late 70s was based on hard coded rules. So when we say hard coded, for those that are doing computer science, it will be clear. But for those that are not in computer science, what we mean by what we say when we say hard coded, what we mean is you write clear instructions to the machine to execute. So when we talk about Eliza, that's the chatbot that was created in the 60s. They had instructions that were written to say, if somebody says hi, you should say hello. If somebody says hello, you should say this. So they had to code everything that the machine will reply when it sees. So it will look for an input from the user, and then depending on what the input is, it has something specific, and that's what we call the rule-based hard coding or programming, where it is given specific instruction to answer. I'm sure all of you will be thinking that this is a very wrong approach to look at things, because even your son, let's assume it's a small child. If you had a son that is just 3 year old, you couldn't teach your son to say, if somebody comes to the house or if you went out and your mates told you, greeted you, you should say exactly this. Whatever you have to do has to be what I've told you to say. No, that's not how things work. Normally, what happens is that a child just learns from his parents. He learns how parents talk and how they act and how they interact. And once the child has already learned, the child is then able to interact with his surrounding and with people at will, meaning that the child then knows the right thing to say at the right time without following a specific rule. So this then led to the development of machine learning. So machine learning can be seen as a replacement of the rule-based AI systems, where we give lots of data to a computer program, and the computer program learns from the data. It doesn't take specific instructions from us. This is what makes it different, and this is the golden golden advantage that machine learning brought. So the fact is, we give it data, it learns from the data, and then it just learns to follow it. It just learns to execute or make predictions or does particular functions. And so in 1980s, that was the beginning of machine learning. However, in the 80s, there was a problem. The computational resources in the 80s was not huge. So it means that computers were slow in the 80s. And again, in the 80s, These algorithms were not as matured as we have today, and there was not even data because the World Wide Web was invented in the 90s. So before the World Wide Web, there was no data. Today, if you said you wanted to see pictures, you could sit down. People sit down on TikTok and watch like thousands of videos. But in the 80s, there was nothing like that. So that is the fourth milestone. And finally, the fifth milestone was early. That's the end of 2010 till now. So from 2010 up to today, we can say that that's the biggest milestone that has occurred, and this has this is because machine learning has matured. And in fact, from machine learning, you could see from this diagram, machine learning is a subset of artificial intelligence that depends on data, and algorithms learn from data. And even within machine learning, we now have a subfield which is called deep learning, where there are algorithms called deep neural networks that we train on huge amounts of data, and they are very good at doing predictions and executing and performing tasks for humans. So, for instance, if you look at Chat GPT, it's based on deep learning. So the truth is, this biggest breakthrough is as a result of like four things. One, we now have powerful computers, which we refer to GPUs, which can be used to train the artificial intelligence algorithm, or I would say the machine learning algorithm, or even more specifically, you could say that can be used to train the deep learning algorithm. And two, availability of data. Now there is huge amount of data available. And then three, there is academic collaboration. Now there is academic collaboration. And the fourth one is the fact that the algorithms themselves that were invented, most of them around the 80s, have now matured. So this, I would say, summarizes the greatest breakthrough we've seen in artificial intelligence. And that is why most times machine learning and artificial intelligence is used interchangeably. And some people even use deep learning. They say deep learning, they are referring to artificial intelligence or machine learning. This is a bit of history that I wanted to tell us about. Now, if you look at machine learning, there are five categories of machine learning. It could even be more than these five, but specifically, these five are the most popular. There are other types that I've not included here, so this is not an exhaustive list, but just for brevity, I've just decided to show us these five. There are five types of machine learning. There's what is called the supervised machine learning. There's unsupervised, there's semi-supervised, reinforcement learning, and self-supervised. I'll give us a breakthrough. I'll quickly talk about supervised learning first. In supervised learning, we have lots of data, and the data come with their labels. So for instance, if you're talking about medical images, let's say we look at these chest x-rays. In these chest x-rays, we have normal chest x-rays, we have those that have pneumonia, and we have those that have COVID-19. So it means that the images have their labels. When we say label, it means when you look at an image, you have a name for the image. For instance, this image is from a normal scan, so the label is normal. This image is for a pneumonia scan, so the label is pneumonia. Now, in supervised machine learning, what we do is we train a model. When we say train, it means teach the artificial intelligence algorithm, teach the machine learning algorithm by showing it these images or the data and hiding the label. We allow the model to make a prediction of what it thinks the label is. And then if it makes a mistake, we force it to correct itself. And I'm saying correct itself, we are not the ones going in to make the correction. It is the model itself making the correction. And this is what makes machine learning, makes it really, really different from rule-based programming. A rule-based programming is the human that says everything that should be done. But in machine learning, we just, especially supervised machine learning, we chuck the data at it, and then the model, by examining the patterns within this data, learns to make a prediction. If the prediction is wrong, it compares it to the label. So in supervised machine learning, we have data and we have the labels for the data. And that process of teaching the model to make very excellent predictions is called training, meaning that once the model reaches an instance where when it sees an image or some data, it can predict the label correctly, we say that the model is fully trained. And when it is fully trained, we can then make a prediction, meaning that if we came with a new image and threw at the model and say, oh, collect this data, given this data, make a prediction, the model can then intelligently tell us, oh, maybe this scan is from maybe a chest X-ray of somebody with COVID-19 or pneumonia or no, this is a chest X-ray that is of someone that has no pneumonia or COVID-19, so it's a normal chest X-ray. So this is supervised machine learning, and this is the most popular form of machine learning, because when you look at prediction, and most of what we see today is based on supervised machine learning. The second type is unsupervised machine learning. In unsupervised learning, we have a huge data set of unlabeled data. So the data is unlabeled. It doesn't have labels. Remember I said the label for data in the previous example is, for instance, this image has pneumonia or COVID-19 or is normal. While in supervised learning, we just have data that have no labels, and the algorithm, mostly what the algorithm tries to do is to detect patterns within the data, to either, for instance, learn associations, to associate some data points with another data point. So for instance, in this example that I've shown, you can see that pictures of many pictures of animals were shown to the algorithm, and the algorithm goes on to what? To cluster them, and this is what we call clustering. It goes on to segregate them to identify these are dogs and these are cats. Honestly, in real sense, supervised machine learning algorithm wouldn't say this is a cat or a dog, but what it will say is I've identified two groups of images. So unsupervised learning does things like clustering, that's identifying, maybe looking at data and splitting into smaller chunks of population based on some attributes that they share. That's unsupervised learning. Next is semi-supervised learning. Semi-supervised learning, it it is a type of machine learning that lies in between supervised and unsupervised learning. If you remember, supervised learning requires data and the labels to the data. Let me take an example. Let me give you an example. For instance, if we wanted to identify, let's say, a disease like cancer, let's say cancer, we have chest X-rays, and we're trying to identify whether these chest X-rays have cancer of the lungs. To teach a supervised machine learning algorithm, we have to collect so many samples of these images and even get professionals or some human beings to label all the images. So if we collected 1,000 images, we need 1,000 labels that will say this has cancer, this doesn't have cancer. And machine learning algorithms are data hungry. 1,000 images is just so small. Sometimes machine learning algorithms are trained with millions of images. So imagine that you had collected 1,000,000 images. It means you have to get someone to sit down and go through all these 1,000,000 images and label them one at a time. And that's very, very expensive. And in fact, that's why many companies are making money out of data annotation today. And so what happens in semi-supervised learning is you just take some sample of the images that you have. So let's say you have 1,000,000 images and you just could label, you had enough money to ask somebody to label, let's say 10,000 images. So what you do is label just 10,000 images and use it to train a supervised learning algorithm. And once the supervised learning algorithm now knows how to segregate between cancer images and those that don't have cancer, then you could then use the model to go on to label the rest of the data that you have, let's say 990,000 images now. So you now go ahead and do that. And that is what is called semi-supervised learning in a nutshell. And so this is the third class. And then with reinforcement learning, I'm just going to show us this picture or this video. If you look at this video, you can see that the chicken is learning to peck on the pink pad, because whenever it pecks on the pink pad, it is given a reward. Look at it. Clearly, it doesn't get confused because it knows that whenever it picks the pink pad, it gets a reward. So a reinforcement learning, that's the idea we use. A reinforcement learning will allow an agent to interact with an environment. Whenever it interacts with the environment, depending on its interaction with the environment, it is given a reward or a punishment. So if the agent, and the agent is the machine learning algorithm, so if the machine learning algorithm interacts with the environment and makes a good decision, it is given a reward. But if it makes a wrong decision, it is given a punishment. And because of that, that repetitive punishment and reward, the model learns to optimize every step that will lead it to get that reward. And by doing that, the model learns to do things excellently well. Reinforcement learning algorithms are used to train all those AI algorithms that know how to play games. So when you hear that Deep Minds created an algorithm that plays a sophisticated board game called Go, and it beat the best game person in the world. The algorithm that was used to train that Go plane machine learning algorithm, that's the type of machine learning that is used there is called reinforcement learning. So we use AI to play game or anything that is similar to that, in reality, the AI model is trained in this manner. We don't give it labels. We just allow it to take the moves it wants to take. But based on the move it takes, if it takes a good move towards winning the game, it is giving a reward. If it makes a bad move towards failing, it is giving a punishment. And because of that, it learns how to play perfectly and it surpasses humans. That's reinforcement learning. And there is so much application of reinforcement learning today. Then there's self-supervised learning. This picture is quite I know it looks complex, and honestly, self-supervised learning is still a new area of research, and people. And I'm not going to talk too much here because it's quite technical. But the fact is, self-supervised learning is a method of learning where we get a huge amount of data that is unlabeled, and then we allow the machine learning algorithm or the AI algorithm to find a way of creating labels by itself. Unlike self-supervised, semi-supervised, because in semi-supervised we have some labels, but in self-supervised it doesn't have any label. We just create a task, and based on that task, the machine learning algorithm learns how to create labels. And when it does this, it means, and if you look at the whole problem we're trying to circumvent here, is that the problem of getting people to annotate the data, because when you have to sit down people and pay them to label the data for you, it gets so expensive. Self-supervised learning is the technique that has been used for ChatGPT, because ChatGPT was trained on, I would say, literally every text that you see on the internet. And so if it was trained on every text that we see on the internet, you might be asking, did we get all the text? If we tried using supervised learning, it means all the text on the internet, OpenAI has to find a way of labeling the text and say, maybe this is a text in English, maybe this is a text in another language, or maybe this text is saying ABC. No, what they did is use self-supervised learning. And yeah, so this is self-supervised learning, and there are other methods of learning. So quickly, I'll talk about how some AI and ML applications. And based on the kind of application that you can use AI for, there are two types of categories, big categories. There is structured data and there is unstructured data. Structured data is data that is well that is well organized. For instance, when you take medical records that have been filled in a Microsoft Excel sheet, this is a structured data. Or financial records that have been filled in an Excel sheet, this is a structured data. Some data that has been carefully entered into a database, a relational database like MySQL or something. This is a structured data. And that type of this solving using AI to solve this problem is quite easy. Honestly, when we talk about structured data, artificial intelligence algorithms are very good at solving that problem. What is more of a challenge is unstructured data. What are unstructured data? There are four types of unstructured data. There is text. The text we see and read is very unstructured. Computers don't see this text, so it is a big challenge. So, and in fact, it is a big breakthrough we are seeing today, that computers are even able to achieve a lot in uh, 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 by processing text. And another unstructured data is image. And then another type of unstructured data is video, but image and video, I put them together because they're quite related, and then audio. And then there's multimodal ML. Multimodal ML is like a combination of all this unstructured data. So when we talk about multimodal ML, is when it could be the input could be text, at the same time image and audio, maybe a combination of all this. So in a nutshell, when we look at unstructured machine learning, a machine learning algorithm that focuses around text is normally called natural language processing, NLP. So, and another when we look at machine learning algorithm that focuses on audio, we call it audio ML. Those focusing on image and video, that area, that field that looks at that is called computer vision. And multimodal AI or multimodal ML is cross-media ML, where it tries to put all these forms of media into one, and which is more complicated. And examples of applications that use NLP is ChatGPT, For audio ML, it's like the Alexa that we have, Amazon Alexa and Siri, and maybe Google Assistant. And for computer vision, is like the Amazon Fresh. I have a video to show us Amazon Fresh, but I'm not sure if StreamYard is gonna allow me to share that video with voice, with audio. And then cross-modal AI, multimodal AI, an example is self-driving cars, because for self-driving cars, they look at images, they process videos, and they look at GPS signals, they process sensors, they even process audio signals. So that's multimodal AI. I don't know whether my audience can hear what is being said here, but I was trying to show us an example of Amazon Fresh. Amazon Fresh is like a store that Amazon has created, where you are able to buy everything without having anybody to look at you. There's no salesperson basically in the shop. That's a practical application of computer vision, where you just walk into a store and then just go on and buy things at will. And after buying things at will, you just walk out, because there are just so many cameras inside that shop, that they just look at you, they look at what you've taken, and they know the amount. And they just, as you're entering, I'll just play it a bit, although you cannot hear I'm not sure if you can hear the audio. And you just need to scan your phone, and that's it. And so that's an example of computer vision at work. And now let me quickly go into AI in medical sciences. Literally, AI has so many applications in medical sciences, and I'm going to give us a few examples of these applications. This list I have here is not exhaustive. So please, if don't take my word that these are the only applications of AI in medical sciences. Let's start from the top. AI can be used for outbreak prediction. So what it means is AI can analyze vast data sources, including social media posts, travel patterns, to predict disease outbreaks. It can provide early warnings to public health agencies, allowing for faster response and containment. That's one. And secondly, AI can be used for genomic analysis. AI assists in deciphering genomic data. And based on people's genomic data, I'm sure medical professionals that will be listening know that genomic data, people have different genomes, and based on different genomes, they should be treated in a different way. So it means that with AI, it can identify genetic variations linked to diseases, and it can also aid in personalized medicine by tailoring treatments based on the individual's genetic makeup. And next, medical imaging. Medical imaging, with AI, we can look at X-rays, MRIs, and CT scans, and analyze their results. So meaning that without having to wait for consultants or for a medical professional to look at X-ray scans, AI can just look at these scans, and it can be used to assist radiologists in diagnosing conditions such as cancer, fractures, tumors, even more accurately. And again, AI can be applied for robot-assisted surgery. Here, AI-powered robots aid surgeons during their procedures, offering precision and minimally invasive techniques. Surgeons can then perform complex surgeries with greater accuracy and reduce patient risk. And next, AI can be used for patient monitoring. With wearable devices, AI wearable devices, patients can be monitored, and this aids in early intervention. For instance, if somebody has the chances of having heart attack, wearable AI devices can just prompt. For instance, like the Samsung smartwatch can just prompt and say maybe there is a sign of maybe heart problem or something. So this is another example, an application of AI. Another application of AI is in medical diagnosis. In general, AI can analyze patient records and provide accurate diagnosis. These systems can help doctors make faster and more precise decisions, hence improving patients' outcomes. And in drug discovery, this is a cutting-edge research now. Drug discovery has started becoming very popular. AI accelerates drug discovery by analyzing vast data sets of chemical compounds and predicting their potential for new medications. So by looking at these chemical compounds, it could find the best medication for a particular disease. And then last but not the least is knowledge extraction. AI can sift through extensive medical literature to extract and summarize relevant information for academics. So you could build a chatbot similar to ChatGPT that is specific for AI for medical research, where people can be asking questions and be giving, and it could be responding with very, very intelligent, well-tailored responses to medical science research. And if you look at this, we can then say that there are many benefits that can be achieved from AI in medical sciences. There is improved accuracy and efficiency of diagnosis because the AI doesn't get tired, unlike we humans, and it's not emotional. It doesn't have emotions. So as a result of that, it could just, if it is accurate, it just goes on being very accurate. If it is efficient, it's not gonna, even if it is efficient on one task, it could do it like a million times without getting tired, which makes it different from humans. And the development of new therapies that, just as I've said, AI can be used for development of new therapies, and hence it could lead to treatment of rare diseases, and it could also give us the understanding of improved understanding of diseases. It can also accelerate clinical trials, and of course then reduction of cost. um, Besides that, then I wanted to talk about a particular professor which has done some research, and it was a it's a testimony that I wanted to show us, but I'm not sure if you can hear the audio, and as a result of that I have to skip that. But it is there's a professor in the United States known as Anna Greca. She has been doing research in identifying kidney disease, and in her research, she talks about. She goes on to tell us how she was able to use in her lab, which is the Greca lab in the United States. They were able to identify a hidden kidney disease that has been devastating a family for decades. The story goes on like this. There was a family who had been experiencing this early kidney disease, and the kidney disease leads to early death. It started from maybe their great father about 100 years ago. He died at the age of 40, 43 or so. And the children, his children as well, his went on to inherit that disease. And it was just like a nightmare to the whole family, in the sense that they didn't live long, and they always had this chronic kidney disease that led to early death. And in their research, she goes on to say that she was able to identify this disease with her research team, and they are able to look at millions of samples. And this is thanks to the new cutting edge research, which is by using AI. She goes on to say that in the past, uh, as a cell biologist, she had to look at slices that were very few. But now with AI, they could look at chunks, millions of data sets, and this has led to diagnosis and findings that are very rare. And so this is one very clear example of where AI is being used. And another thing I wanted to mention is that advanced nations like United Kingdom are investing heavily in AI. For instance, this is a news clip from 30th August this year. The UK has committed a substantial amount of 13 million pounds. And if you look at it, 13 million pounds, if we were to convert it to Nigerian currency, is about 13 billion naira. And this is, if we start and compared again, last year's budget maybe 16 trillion, right? So they have budgeted something that is close to our last year's entire 2022's budget on use how to or research that will lead to developing AI for healthcare. And this is to tell us that countries AI is the future, and many people are invested in it. So without much further ado, I just want to talk about a few challenges of AI. While it poses so many advantages, AI has a number of challenges. For instance, data privacy. We know that AI requires data for its training, and when we apply AI for medical science research, the data definitely will come from us as humans. So there are privacy concerns, because if you collected patients' medical records and then went on to train AI algorithms without their consent, that could be a big problem. So there are data privacy concerns, and there are also regulatory compliance issues. AI applications in healthcare must comply to certain regulatory frameworks, and that can also be a challenge. And thirdly, there's data quality and integration concern. There's the challenge around data quality, because if you use good quality data, the AI learns to perform the function you want it to perform well. And if you use bad quality data, the AI then doesn't learn to do its work properly. So it means that there is also a challenge of getting high quality data and making sure that it is integrated well. And then user acceptance. User acceptance is another issue. Healthcare professionals like doctors, consultants might have that, might not see AI as might not see AI as the future, or they might see AI as something that's coming to replace their jobs. In reality, my personal opinion is that AI is not supposed to replace doctors or replace medical practitioners or medical researchers. I believe that AI is supposed to work hand in hand with we humans, because we cannot just let AI to make decision on human lives without any human intervention. Then there's liability and malpractice challenge. For instance, if AI goes to make a bad decision, who are we going to hold responsible? Is it the person using the AI, or the person that developed the AI, or who? So this is another challenge. And then there's data bias. If you use AI to train, if you train AI on data that comes from Europe, then that AI algorithm is very good at diagnosing people, let's say, from Europe. If you took that AI algorithm and now took it to Africa and applied it on African people, it might give bad results. So data biases are also a big challenge. And then there is the over reliance issue. If AI comes and it turns to be very good, we might tend to be very over reliant on AI, and then a problem can just creep in. Where, for instance, if AI goes to make 98% accurate predictions, but the 2% false predictions that the AI makes, if there is no human oversight, then that could go on to affect a huge number of people, and it could lead to deaths and other things. And again, AI is not human. AI doesn't have emotions, so AI lacks empathy, unlike we humans. And that's why I don't see AI as replacing humans. I see AI as working hand in hand with humans. Finally, I'll conclude by saying that artificial intelligence is transforming medical science in many exciting ways. AI is not just a buzzword, it is changing healthcare dramatically. AI can speed up diagnosis, help develop new drugs, and improve healthcare through analyzing data and making predictions. The future looks really bright. I believe that it is important for AI experts and medical professionals to work together with academics. By collaborating, they can fully tap into AI's potential. And I also want to say that AI can benefit healthcare globally, including Africa. It can improve disease detection, telemedicine, and access to healthcare, especially in rural areas. The message is clear: embrace AI in healthcare, invest in research and education, and encourage innovation. Thank you.
Thank you very much. I am really captivated by the conclusion because it's really, really strong. And if we have any journalists or any someone that has access to the media, those are golden words that's supposed to reach our policymakers and people that have the say into our health activities. Thank you very much, our speaker, for today and for this enlightening talk. I, among others, have really get enlightenment about how machine learning and artificial intelligence do work. And as before we delve into the question and answer session, I would like to give announcement to our viewers and listeners at the moment that this is one of many series because of how important artificial intelligence is. Our speaker has agreed to give series of webinars highlighting moving deep into aspects of artificial intelligence especially when it relates to healthcare research and medical applications. So personally, I would like to be a little bit selfish and start with asking question which is of my own. I would like to apologize to all the presenters. I can see we have only one question in the comment section. I encourage listeners to post their questions, and we will post it to our presenter. So, my own personal curiosity is, um, with all the things that, and especially what you said about um, artificial intelligence not replacing humans, rather it will only be of assistance to humans. I just want to ask, do you is it possible to think that there are some knowledge in which a person is not supposed to kind of consume it at the moment and leave it for the AI to be of assistance? And now we can look forward into an era in which researchers and medical doctors would only deal with the aspect of critical thinking. And because now in the on normal school systems we have, you students will be given a big chunk of handouts and all theories for them to just go, and usually they have to cram it and pour it in the exams. And when you have AI that will be able to do that, can we say that, okay, we don't need that? We only now need to train people that will do the critical thinking, thinking ahead, inventing new things. Can we have that kind of thought, or that is a limitation to AI in that aspect?
Thank you so much, Zaid, for asking this question. Um, I would say that I believe AI. I know many people have this. People could have differing opinions with me. Some people think that AI should replace human beings completely. Some people think that AI cannot do it at all, so AI should not even come close to medicine. I take the middle part. I believe that AI should work hand in hand with humans. Um, and I wouldn't say that AI, because it is not working hand in hand with humans, we should just send humans to go and do the technology and then let AI do the understanding. No. What I want us to believe is that there is still that need for subject matter expertise. We need that subject matter expertise when we're curating the data, when we are labeling the data. So when I say label the data, that's annotation. Because when, for instance, if you took images of people with uh, pneumonia and those without pneumonia, let's say chest X-rays, I, as a non-medical practitioner, just see them as the same. I don't understand anything. So the medical practitioner, because he has read all this in school, knows it. Even by looking at the images, you'll be able to say. So, for instance, if you ask somebody to collect 1 million images for you, people like me who just cannot look through and do anything. But the expert then looks through and he's like, yes, I think that data is right. Secondly, then annotation in putting the labels on saying this is pneumonia, this is not pneumonia. That is also very important. And again, there's that need for subject matter expertise where the expert knows what region of the chest to look at. So honestly, I believe that even the way we collect our data, the way we format the data, the way we push it to the AI, it all depends heavily on its subject matter expertise. Despite saying that, I believe that AI will be able to replace very repetitive jobs.
Mhm.
So, for instance, there are some repetitive jobs that a professional should not be doing. We should free up our doctors and our medical researchers to go and do that cutting edge research. Repetitive things like looking at images and giving verdict on them maybe will be replaced by AI. Well, but the AI will, of course, not just give the answer and then we just tick it off. No, I believe what should be done is AI should maybe look at some data and then if it gives the verdict, then a human oversees and looks at it. Sometimes there are things, and because the output that comes out from AI is always a probability, and that's a good thing. So when AI says, I think there is pneumonia here, it doesn't say pneumonia. It's actually what it says is, I think I'm 90% confident that there's pneumonia, or I'm 10% confident there's pneumonia. So based on that confidence, you will be able to know that some things are clear cut gotten by explained well by the AI. So if AI is 99% sure of something and we believe the AI model is good, then we might take that as yes. But if AI is borderline saying I'm 70 something percent confident, then a human needs to look at it. But in a nutshell, I believe that this tools should be used along with human oversight, and it wouldn't replace humans. Thank you.
Thank you very much. um, so the next question comes from Umar Ahmad Aliyu. He said, "Please, I'm a medical doctor and hoping to venture into AI machine medicine with interest in medical images slash drug discovery. I don't have any computer knowledge, but I'm very good fast learner. Please, how will I start?"
This is a very, very good question. Honestly, is a fantastic question. One, I would say that most people shy away from this because they think that AI, for you to do AI, and in fact, there there has been people, AI professionals, and those that are right academically have been trying to debunk this misconception that you must be 100% good in maths, 100% good in programming, 100% good in statistics before you can work with AI. Yes, these three things are very, very important. However, there is what we call democratization of AI today, where there are a few very, very, very technical experts that work in that area, and there are very few. And then there is a group of AI developers that do not need that very in-depth knowledge before they can utilize AI or even use it to do their works. So in a nutshell, what I'll say, for you to start, there are a few programs online. For instance, there is Professor Andrew Ng. Andrew Ng is one of the number one people that has benefited the AI community. He has democratized AI. He has so many excellent courses like Introduction to Machine Learning. There is the Deep Learning AI specialization where he tries to teach you AI without the maths. So he says, "Oh, calm down. You don't have to learn the maths at this point." That is for people that are not that lack that mathematics background. And honestly, you go on and continue from there, and you'll be able to do things. Besides that, there's a course called Fast AI. Fast AI is also very good. With Fast AI works on the assumption that you know how to code. So with that one, you just learn how to program. If you know how to program, you could use that Fast AI framework or library to then build AI tools. And that's also very, very good. And the truth is that these two courses that I've mentioned, the Fast AI and the Deep Learning AIs, Fast AI by I can't remember the author, but just Tim Howard, I think. Just write Fast AI, and then there's Deep Learning AI specialization that is taught by Professor Andrew Ng. These two are very, very good starting points. And of course, that's why we're here today, and we intend to take this as these baby steps, and we hope that this series would be a learning process for all of us. Maybe we could just turn this into a monthly session or quarterly session where we can be learning this together. Thank you.
Thank you. So we have some goodwill messages from the World Mr. Presenter by Muslim Muhammad. Uh, Omar Ahmad Ali said, "This presentation makes my day." Wow, that's nice. I hope you're close by to have taken note about the answers given by the presenter. And we have another question by Alpha Adam Hussein. "Thank you for the presentation. Want to ask how I could leverage on AI in medical literature search. Thank you."
So the question is how to. Thank you so much for the goodwill messages, and this is a very good feedback for me.
Yeah.
So it will kind of reinforce me, a form of reinforcement learning. Thank you so much, and maybe that will make me come back again and again. Um,
We are happy.
so with regards to the question of how can you use AI for medical uh, literature search, right? For search, and I think there are some AI tools today that are being, for instance, ChatGPT is being integrated into the Bing search, right? So with Bing search, I believe that then it can help with search for literature. And I think Bard, Google Bard is also connected to the search, and so probably using Google Bard AI will help you with that search. However, you must take their outcomes with a pinch of salt. Like I said, AI models are probabilistic models. Sometimes they could give you things that are true, and sometimes they might not be true. And maybe this can be a good project for you to think of, uh, Alpha. Probably this should be a project for us to work on creating an AI tool for specifically doing medical literature search. Thank you.
Okay, Alpha, I hope you have that, and probably you will be a consistent person out to our webinar series. And this, I think, is from Sadiq Muhammad. Thank you for this wonderful presentation, sir. Okay, my question is that as a medical student, what are the first steps to learn AI in relation to health? I think partly we have answered this question, but I
Yeah.
would the chance to the presentation more like that.
Yeah. So again, I would say that the first step to learn this is to believe that you don't have to have programming or mathematics or all those very engineering focused backgrounds for you to do AI. So that belief is a very important thing. Then secondly, you need to take some steps. And like I said, um, the first AI course requires some bit of programming, but it doesn't require mathematics or understanding of the maths behind the scene. So if you want to learn using fast AI, that's a very good starting point. But before then I'll advise that you start learning programming. And the programming language that is popular today is Python. Python is quite easy to learn, and you could start by learning this. And there are just so many free online resources. For instance, W3 Schools has Python courses that you could just be doing. You could start by doing looking at Python. If you wanted to start today, just dedicate 15 minutes of your day every day to go to W3 schools and look at something in Python. Before long, you have learned a lot. And after learning Python, then it means that you could then go on and start the first AI course. So let's say you started looking at Python today and got familiar with Python. After a few months, let's say 1 or 2 months, you could start looking at the first AI course. And as a matter of fact, the first AI course doesn't require so much understanding of what's happening behind the scene. They will start teaching you how to build real world applications, and that's a good thing. They'll show you with some pictures and maybe you replace it with your own medical images, and once you start seeing the result, that result is going to reinforce you. It's going to be a very good feedback loop. Seeing yourself achieving excellent results, I'm sure, will push you as a human to even start asking that question of how did I even achieve this, and then you wouldn't know when you have started reading further, and I'm sure your journey is going to be a very smooth journey. And there are many people that have gone into this area of research that didn't do a PhD in this or masters in computing or research or engineering. There are people that don't even have a bachelor's in engineering that are doing it today. So just have the belief and start working towards it today.
Thank you. The time is not by our side. So that is something from Muhammad Umar Zaga, who asked a question that I think we have answered it similarly. So as Shoaib Ibrahim, Muktari Isa, I think we have answered similar to these questions, and it's all about advice and the use. But this one is asking, how reliable are the sources, which have answered the most interesting, I think, is this one from Ahmad Olatunde. I'm a researcher and my target is in drug discovery. How do I bring in the aspect of AI into this my field? Any recommended tool or website of interest?
Yes, I will reiterate what I said earlier, and probably I can share these links that I've been referring to with the host, Mr. Zaid. I'll share those links with our host today, and please, you can maybe reach out. I know Zaid will find a way of sharing these links. I'll share with us, and I'm so happy hearing that many people really want to go into this, and this is the kind of motivation we want. And I'll give you an example. I'm aware of time, but I'll still give us an example since this question keeps on coming. I had a colleague back in about 7 years ago or more. She was a lady. She did her background is in medicine. So I think she did her bachelor's in cancer therapeutics or something. You correct me, medical professionals, if I didn't say it right. She went to do her master's in that same area, and she was looking at cancer. She had no programming knowledge and nothing, and she came to start a PhD in something that was related to using computer vision, that's machine learning, to understand medical images. So she started like that, and she one believed that she could do it, and she took all those courses. I remember clearly that we worked together, we guided her, many people in the lab guided her, and she took all these baby steps. And today she's working in a big company. And I'm telling you, not even as a medical practitioner, as a software engineer. So that's to say that if you have the belief, you'll be able to achieve all this. Thank you.
Yeah, thank you. So, another question is, I think is this is something that we have by Lawan Tijani Bakar is all about advice. And for the okay, what is the advice? I think that the presenter has already delved into that and answered it judiciously. So we can go over that. So this person is asking, can we have a video clip of this session? Yes, by Saidu Jibril. Actually, every bit of our webinar is always available on our social media handles. You can access it at any time. Even if you did not make it to our own webinar, you will have a full session there. And if you have any question, you can reach us on our website www.biortc.com, and there you can have an email, our official email. You can send a message and we will refer it to the presenter. And if he answers, we will get back to you. So it's fully accessible at any time. We are available on Facebook, Twitter, YouTube at BioRTC Nigeria NIG. So if you just check us, follow us, subscribe to our channel. Whenever we have new something, you will be notified and you will stay updated on activities. Our main aim is to continue enlightening and bring people, researchers like from the medical field and even diverse areas into the area of critical thinking so that we solve the problems of our nation. And with this, if we create a big community, we hope it will reach the policymakers, and the policymakers will eventually. The presenter just presented about 13 million pounds investment of the UK government in AI only. In Nigerian naira, you're talking about 15 billion naira. That is a huge amount of money. And Nigeria can be at that stage, but we need the community first. We need people that are thinking in that direction. We need to find within this community someone that will be a senator, will be a minister. And for him at that mantle of power, he will be able to push in our agenda, and all those things will work towards bettering the life of our own people, bettering the livelihood of our own family, of our own friends in Nigeria. And that is the primary purpose of the webinar series and everything. We are here to enlighten, to create a community, to create sense of entitlement to problems of our own so that we don't look to other places. We have a lot of goodwill messages from people that have really enjoyed the webinar today. We are really happy you enjoyed it. And talking about policymakers, we have only a few minutes. I would like to take this time to bring to the notice of our own people. BioRTC, actually, Biomedical Research and Training Center, is established with the sole purpose of creating the community of scientists, researchers, thinkers, critical thinkers into solving problems. And we have achieved a milestone, I think, last week. We were able to get the attention of the government, and the government have come here to the United Kingdom and visited some influential research institutes, all in the name of seeking collaboration and in support of BioRTC. So this is actually a great achievement to BioRTC, because we are now having the full support of the government, full support of policymakers, and the founder, which the government have been supporting, I think, for the past year or two, is even the government have created a special position for special advisor to His Excellency the Governor of Yobe State on science innovation, which is the first of its kind. So actually, we want similar things to occur in various states in Nigeria so that we have the greater community, policymakers involved in science, encouraging scientists, so that we will have mentors and we have students looking up to mentors, and we will have generation of scientists that will come and solve our problems. With this, I think we have only seconds on the clock, and we would like to send our appreciation to the founder of BioRTC, Dr. Mahmoud Bukar Maina, whose efforts have led to this, and of course, our presenter, who is Dr. Ali Bukar Maina, for sparing his time. He's a very busy man. If I mean busy, he is really busy. It's really busy. And for him to spare like 1 hour of his time to talk to us today, we cannot thank you enough. And to our team, to those that have followed us and followed this presentation from the beginning up to the end, we also thank you for joining. And to those that will see us subsequently on our social media handles, we say thank you and stay tuned. Follow us on social media and catch up next month or less, or before, or in less than a month for another interesting series, or another interesting session of the webinar. Thank you and goodbye.
Thank you so much.